Carbonates. Right, so limestone we've come across quite a lot, and we know that it's mainly calcium carbonate. The most commonly occurring carbonate containing ore. Okay, there's lots of it in the Earth's surface, in the Earth's crust, and we use it for lots of different applications. So we'll talk about some of them in a little while. This is what's called a kiln, K-I-L-N, kiln, and it's meant to heat the calcium carbonate to very high temperature, and the whole thing rotates, I think. So it rotates and heats it, it constantly is moving it to cause thermal decomposition. Okay, so we heat it up and it thermally decomposes. Now you might remember this from the blast furnace. So when you heat calcium carbonate, it thermally decomposes to give. What does it give? Have a go. It gives calcium oxide and carbon dioxide. Okay. Now these diagrams, they're quite nice, but they kind of might make you think there's some kind of covalent bond going on here, and there's not. There is here in the carbon dioxide, but there's not here. This is an ionic attraction, isn't it? Ca2 plus and O2 minus. But it just shows you what's present, essentially. This calcium oxide is called quicklime because it's the first thing you get when you heat calcium carbonate. Quicklime. Okay, that's a chunk of calcium carbonate. So there's the equation again. Thermal decomposition must be endothermic, remember. The white calcium oxide is called quicklime. If we add a small quantity of water, just a little bit, then an exothermic reaction occurs, which is actually used. When's it used? It's used for heating up. You know, when you've got these portable food containers, that when you mix them or shake them or push something or pull something, they get warm automatically. I think they use calcium oxide. I think they use quicklime in those. When you add a little bit of water, then the water adds to the calcium oxide to form calcium hydroxide. Calcium hydroxide is CaOH twice. This is an exothermic process. I don't like this plus heat. It should be delta H is negative. It's an exothermic process. This forms something called slaked lime. Okay, and slaked lime is calcium hydroxide. It's very slightly soluble in water, so we use it to make lime water, which you've heard of. And lime water is used to test for carbon dioxide gas. What's the reaction between lime water and carbon dioxide gas? Have a go. There you go. Calcium hydroxide, lime water, reacts with carbon dioxide to give calcium carbonate. And this, my little chemists, is why it turns milky. They call it a milky, or it goes cloudy. Milky white precipitate is formed of calcium carbonate. So we've gone full circle. We did calcium carbonate, thermally decomposing to give quicklime, with water to give slaked lime, and slaked lime would give calcium carbonate. No wonder it's called the limestone cycle. Okay, you can have a look at that cycle. I'm not going to go through it because it seems fairly clear, but I think it's useful. It's a pictorial representation of just what we've talked about. Now, you need to know some of the uses of limestone and lime. So you can have a look in your textbook. It's a pretty important material used in buildings and roads, and used to make concrete, so cement, and then on to make concrete, used to make mortar, which is the thing that goes between bricks. It's used in the process of making glass. It's used to neutralize acidic soils. And also, we've seen before, it can be used for scrubbing acidic gases and liquids. Scrubbing is the cleaning process. So chemical plants and power stations, we can use some form of calcium carbonate or calcium oxide, calcium hydroxide. Flue gas desulfurization being one example of this. So remember, you can pass the gases from the power station through calcium carbonate or calcium hydroxide, and it removes the acidic gases. Okay. Right, there you go. That was quite a short section, I know. Have a look at the pages and answer the questions.